Very good afternoon to all. Today's topic is based on FIR filter using the windowing technique. Now we have a problem, that is we have to design one ideal low pass filter, specifications as given. So using the windowing technique we have to generate our FIR filter with the frequency response. This is a given problem. So we have to solve this problem, and given we have to solve the problem using the Hanning window. Specific window is given, that is a Hanning window. So given HD of e power j omega, that is equals to 1 for omega minus pi by 2 to plus pi by 2 and 0 elsewhere, and given n value which is 11 odd. Now step 1. So the very first step is, first we have to observe whether the given HD of e power j omega which is symmetric or antisymmetric. Given n value is equals to 11. 11 means it is odd. Now we have HD of e power j omega is equals to 1 for minus pi by 2 to pi by 2, and it is 0 between pi by 2 less than or equal to mod omega less than or equals to pi. So remember, it is mod omega. It means minus pi by 2 to minus pi, it is 0, as well as plus pi by 2 to plus pi, it is a 0. Then if I draw this frequency response, then x-axis is omega, that is minus pi by 2 to plus pi by 2, and remaining minus pi to minus pi by 2, it is 0, as well as plus pi by 2 to plus pi, it is a 0. Now if you are identifying this HD of e power j omega, you have symmetric property. So this from 0 to pi by 2 is same as minus pi by 2 to 0. So therefore this is given frequency response is symmetric and n value is odd in nature. So this is the first step. Second step is finding the HD of n from using the formula 1 by 2 pi integral minus pi to plus pi HD of e power j omega into e power j omega and d omega. From the given characteristics we came across the 1 by 2 pi, we have the integral which is existed between minus pi by 2 to only plus pi by 2. The HD of e power j omega value is 1 into e power j omega and d omega. So therefore integral of e power j omega n is e power j omega n by j into n, and the integral is between minus pi by 2 to plus pi by 2 multiply by 1 by 2 pi. If I substitute the upper limit instead of omega, so e power j n pi by 2 minus e power minus j n pi by 2 divided by n into j. So we know that sin theta n theta formula is e power j theta minus e power minus j n theta divided by 2j. So same I am writing down here. So HD of n is equals to sin n pi by 2 divided by n pi. Give it as equation number 1. So here the n value is between minus infinity to plus infinity. Minus infinity between to plus infinity. Now using the windowing technique we are truncating down this minus infinity to plus infinity value to minus of, that is some particular range between, using the linear phase relation, minus of n minus 1 by 2 to plus n minus 1 by 2. Given the order of the filter is n is equals to 11. Now using the step number, next step number 3. find the filter coefficients. Find the filter coefficients as well as h of n is equal to, using h of n is equal to hd of n into omega hn of n, that is Hanning window. Now individually find out hd of n for sine of n pi by 2 to n pi between n value, that is because it is a symmetric in nature, n value between 0 to n minus 1 by 2. So therefore if I substitute the order of the filter, then it is 0 to 5. So in general it should be minus 5 to plus 5. If you are taking the 0 to 5, same values for minus 5 to 0. Now if I substitute n is equal to 0 in the above expression, I will get 0 by 0 format. So using the L'Hospital rule, sin theta tends to 0, sin n theta by n theta is equals to 1. So using the same L'Hospital rule, because whenever you are getting the 0 by 0 format, you have to use the L'Hospital rule. Then if I substitute n is equal to 0, then hd of 0 is equals to limit n tends to 0 sin n pi by 2 divided by n pi only I have multiply and divided by 2. Therefore you will get hd of 0 value as is equals to 1 by 2, 0.5. Now substitute n is equal to 1 in the same equation number 1. Then hd of 1 is equals to sin pi by 2 divided by pi. Sin pi value is 1 by pi is equals to 0.3183. Next substitute n is equal to 2, 3, 4 up to 5. So these are the coefficients for different n values, n between 2 to 0 to 5. So same n value between minus 1 to minus 5. Then using Hanning window. So the Hanning window formula is, now we are finding out the Hanning windows also. So Hanning window formula is omega hn of n is equal to 0.5 plus 0.5 cos of 2 pi n divided by n minus 1 between n value minus n minus 1 by 2 to n minus 1 by 2. 0 otherwise. Now again I have to substitute n value between, given the order of the filter is 11. So therefore the formula is holds good for n value between minus 5 to plus 5 and 0 otherwise. Now using the same symmetric property, if I substitute n is equal to 0 in Hanning window, then is equal to 0.5 plus 0.5 cos 0. So the value is 1, 0.5 plus 0.5, 1. Next substitute n is equals to 1. So we have the positive value is equals to n is equals to negative value 0.5 plus 0.5 cos of 2 pi into 1 divided by n value is 11. 11 minus 1, that is 10, is equal to 0.5 plus 0.5 cos of pi by 5. The value for n is equals to 1, n is equal to minus 1 is 0.9045. Now for n is equal to 2, then the Hanning window coefficient is equals to, if I substitute the same, 0.5 plus 0.5 cos 4 pi by 10, 2 pi by 5. The value for cos 2 pi by 5 is 0.65. Next, n is equal to 3. Then the Hanning window coefficient is 0.345. For n is equal to 4, substitute n is equal to 4 in the above expression, you will get 0.0745. Next, n is equal to 5. Then the last value will be 0. So why it is 0? 0.5 plus 0.5 cos of 5 pi by 10. So 5 value 5 into 2. 10 pi by 10. Cos pi value is minus 1. 0.5 minus 0.5, the value becomes 0. Next step is step number 5. Find the filter coefficients using the Hanning window. So therefore h of n is equals to hd of n multiplied by the Hanning window coefficients. If n is equal to 0, then h of 0 is equals to hd of 0, the desired response, with the windowing response. If I multiply hd of 0 with whn of 0, the value will be 0.5 into 1, 0.5. n is equal to 1, h of 1 is equals to, the value at n is equals to 1 in both the desired response and windowing response. So therefore 0.3183 into 0.9045. So 0.287. Next, n is equal to 2, then h of 2. So we already know that it is symmetric in nature. So whatever I have calculated for n values, same values for minus n also. Next, hd of 2 into the windowing, the value at n is equals to 2. So the value will be 0 into 0.65 is equal to 0, is equal to h of minus 2, and this value is equal to h of minus 1. If n is equal to 3, h of 3 is equal to h of minus 3. Again multiply the coefficients in the both the terms, then you will have minus 0.106 multiply by 0.345 is equal to minus 0.0365. At n is equal to 4, similarly at n is equal to 5. The coefficient, filter coefficient is 0. At n is equal to 5 also, the filter coefficient h of 5 is equal to h of minus 5, that also 0. 0.06 into 0 is equal to 0. Here it is 0 into 0.0945. Again it is 0. So these are the filter coefficients. Next step is regarding the finding the transfer function of non-realizable filter, and it is given by the formula as h of z is equals to h of 0 plus summation of n is equal to 1 to n minus 1 by 2, h of n as a common, z power n plus z power minus n. Now h of z will be equal to, so we got from the above analysis the h of 0 value is 0.5 plus substitute the order of the filter is 11, 11 minus 1 by 2, that is 5, h of n z power n plus z power minus n. Now elaborate the summation as 0.5 plus h of 1 into z power 1 plus z power minus 1, n is equal to 2, then n is equal to 3 and n is equal to 4, then n is equal to 5. So h of 4 into z power 4 plus z power minus 4 plus h of 5 into z power 5 plus z power minus 5. Now we have the h of z after substituting all the coefficient values h of 1 to h of 5, 0.5 plus h of 1 value is 0.287, z power 1 plus z power minus 1, then the h of 2 value is 0 as well as h of 4, h of 5 values are zeros. In the remaining we have only two leftover terms which are 0.0365, z power 3 plus z power minus 3. So this h of 2 value 0, h of 4 value 0 and h of 5 value also 0. So in this case those values are zeros. If it is existed, you have to substitute those values. Next, give it as equation number 2. Number 7 is based on finding the transfer function of realizable filter, that is equals to h dash of z is equals to multiply h of z with z power minus of n minus 1 by 2. So from the equation number 2 we have h of z, therefore h dash of z is equal to z power minus 5 into h of z. So h dash of z is equals to 0.5 multiplied by z power minus 5 plus 0.287. If it is multiplied by z power 1, we will get z power minus 4. If it is multiplied by z power minus 1, z power minus 6, minus 0.0365 z power 3 into z power minus 5 is equals to z power minus 2, minus 0.0365 into z power minus 8. Now next step, so rearrange this. H dash of z is equal to, first term is minus 0.0365 z power minus 2 and the second term is 0.287 z power minus 4. Third term is plus 0.5 z power minus 5. Next term z power minus 6 and next term z power minus 7 is missing, that is 0, minus 0.0365 z power minus 8. Next step, so give it as equation number 3. Step number 8 is based on finding the causal filter coefficients. Using the equation number 3, we have identified that h of 0 coefficient, h of 1, h of 3, h of 7, h of 9 and h of 10 coefficients are missing. Those are is equals to 0. And also we have identified that h of 2 coefficient is equal to h of 8 coefficient, that is equals to 0.0365. Then we have h of 4 coefficient is equals to, from the above analysis, h of 4 coefficient is equal to h of 6 coefficient. So therefore the value is 0.287 and the last value h of 5 is equals to 0.5. So these are the causal filter coefficients from the above equation number 3. Next, step number 9 is based on writing the formulas for symmetric frequency response and n is equals to odd value. Finding the magnitude response for a given frequency response is symmetric in nature and n is equals to odd. Now to find out the a of 0 value, then to find out a of n value, we have a formula is 2 into h of n minus 1 by 2 minus n. Now substitute n is equal to 0 value we got already, it is 0.5. Now n is equal to 1, the magnitude response, that is A of 1 is equal to 0.574. If n is equal to 2, the A of 2 will be is equal to 2 into h of 3 is equal to 0. Now again n is equal to 3. The A of 3 value is equals to 2 into h of 5 minus 3, that is 2. 2 into h of 2, h of 2 value is 0 minus 0.0365. So is equal to minus 0.075. Now A of 4 value is 0, A of 5 value also 0. Next, the obtained value we have to find out using the magnitude response. The magnitude response is magnitude of 0.5 plus 0.0574. If I elaborate the summation, so cos omega minus 0.073 cos 3 omega. Now find out this magnitude in terms of dBs. To calculate in dBs, apply 20 log on both sides. 20 log of h of e power j omega. Magnitude. If omega is equal to 0, then if I substitute in the equation number 4, then the magnitude will be is equals to 0.5 plus 0.574 cos omega value, that is cos 0 is 1 minus 0.073. Find out and finding the using the 20 log of the answer. 0.5 plus 0.574 minus 0.073. The value will be somewhere around 0.001. This is the magnitude, yet omega is equal to 0. Similarly, so the table for different omega values, magnitude as well as phase values. First, omega is equal to 0 degrees. The magnitude in terms of dBs. So this is the magnitude and the magnitude in terms of dBs. So 0 degrees 1.001. Next, omega is equal to some 15 degrees. Next, omega is equal to 30 degrees, 45 degrees, or else, so omega is equals to 30 degrees. Then 30 plus 30, 60 degrees, 90 degrees, 90 plus 30, 120 degrees. Next, 150 degrees and 180 degrees. This is a table which shows the magnitude response with normal units and with the dBs. Using the same this table, we have to draw the characteristics of the low pass filter. Now, x-axis is omega, and y-axis is the magnitude in dBs. 0 dBs, then it is decreasing. Then we have x-axis is omega, then 30 degrees, 60 degrees, 90, 120, 150 degrees and 180 degrees. Now the x-axis will be, y-axis will be the magnitude in dBs. If you are identifying in the table, the magnitude is always decreasing. Suppose if I have 0 dBs, so this is magnitude of h of e power j omega with dB, 0 degrees. So I have considered the y-axis as 10 dBs difference, 0 dBs, minus 10 dBs, minus 20 dBs, up to maximum is minus 60 dBs. Then we have at 0, omega is equal to 0, the value is 0 dBs. Again for omega is equal to 60 degrees, we have the dB is minus 1.31. Again for 90 degrees, we have around minus 6.02. Again at 120 degrees, we have minus 17 dBs. So minus 17 dBs. At 120 degrees it is decreasing. So first it is maximum, slowly it is decreasing. Again the peak value is at 120 degrees. Again at 150 degrees we have minus 22. So somewhere at 150 degrees minus 22 dBs. At 180 degrees we have minus 60 dBs. Now this is our final magnitude response. If I take omega value, more omega values, it will be like decreasing. So this is our practical low pass filter frequency response or characteristics. Frequency response of low pass filter. Thank you so much.